Okay, so, welcome. I'm the Chronic Phoenix, and this is the platformer that I'm currently working on, or a platformer project. It's not really a specific game right now. Had a name, Destination Level Design, but that's not really a accurate term for it anymore. So, we're going to be moving on from that. Now it is just the unnamed platformer project, and I'll figure it out as I go. Last time was a pretty short stream, just went over some combat stuff, and today, don't know how long I'm going to go. Not feeling too great, but gonna give it a go. Fatigue has been absolutely brutal for the past, 8 days, 9 days, something like that. Time's been hard to keep track of. And though I've begun actually managing to sleep better, it has not really helped at all. Chronic fatigue. So, yeah. But I want to make some progress, and frankly, I'm not going to get anything done if I'm just doing it on my own. Just going to keep getting distracted, doing other things, watching stuff, trolling through social media, the usual. So, I decided to try streaming. We'll see. We'll see how it goes. Okay. So, at the end of the last stream, or not at the end of the last stream, but the last stream went over some progress on the combat, and I talked about a few things that I want to add. Mainly, some of the stuff that I wanted to add was separating each attack into its own sort of class that would contain, custom class that would contain details about the animation, timings for the colliders, etc., etc. And I managed to do that between then and now. So if I go over to this enemy combat test, might be a bit, let me just close up all these. Right here we have a custom class called Attack Info, and this is an array of them. Right now the enemy has 3 main attacks. If you open this up, it might be hard to see on stream. I don't really have a good way of zooming in on it, but each one is defined by a name, which is the name of the animation state in the animation state state machine animator thing in Unity. Each of these is an animation, and they're all connected by lines. They're all connected by pathways, which are sort of how one animation goes to the next. And those can be controlled either via conditions or by an exit time. If you have an exit time set, as soon as the animation reaches that portion in its timeline. So in this case, this line is coming from any state, meaning that this animation can follow or come from any other animation that's currently being played. Doesn't matter. Otherwise, you have to define a specific line between one animation and the other. Coming from any state, any of the attacks, and any of the getting hit animations come from any state. And in this case, if an attack 0 was going to come from an attack 0, if you were going to do the same attack twice, it would have to wait until the very end before it started playing again. If has exit time was checked, it's not, for a couple reasons, but yeah. So you have all those animation states, and that is what is defined by this name in the enemy in attack info, the name of the state, so that I can track it. Then you have collision timing, which is just I'm just using a vector 2. It's the sort of in between these two timings, these two normalized timings for the animation. And so the normalized time is a value 0 to 1 that represents the total amount of time an animation takes to move. So if, an animation took 5 seconds, the normalized time would still go 0 to 1, but that would represent going 0 to 5. So it 0.5 on the normalized time would be 2.5 in the animation time. So collision timing is based on the normalized time of the animation, how basically just the percentage of how far the animation is done. And if the animation is between these two values, then the collider for the weapon is activated, and the weapon can actually hit things and cause damage. Outside of that time, it cannot. Then we have the amount of damage that the attack will actually do if it hits, and then we have these two values, blockable and dodgeable, which are just booleans. Those aren't in use right now. And those, of course, would allow you to decide if an attack was... so if you had like a power attack that could just cut right through a shield or defenses or something, you would uncheck blockable. And then maybe there's some special attacks that you can't dodge either. I was recently playing Returnal, which is a third-person roguelike with the combat. It's sort of like Mass Effect Andromeda's combat, except that the enemies, all of the attacks the enemies do is basically a bullet hell, aside from their sort of physical attacks where they attack you, but they have all sorts of range attacks, which are basically just a third-person action bullet hell. Fantastic game. I actually just finished the secret ending earlier today. Wonderful game. But there's later on, there's a couple attacks which are not dodgeable, and some of that stuff has been inspiring me in different ways that I can expand out the enemy systems, or at least test them, because I have no idea what this project is going to end up being like. So I'm just sort of testing out everything at this point. And then the very important thing is I finally managed to get external forces wrapped up into its own custom class, or rather, I had external forces wrapped up into a custom class, but now I've actually made it accessible in the editor, so you can define it. So an external force is basically the system which is applied to any moving object by anything outside the moving object. So if the player hits like the bounce pads, or if the player takes damage hitting spikes, or if the player's in a wind tunnel, all of those apply forces through this external forces system. And I actually use that to call some internal forces as well. The player's dodge ability is based on that for dashing and stuff. This allows you to basically add in a specific force for each attack. So before, if you got hit by some sort of damage system, there would be just one universal knockback. This allows you to define exactly what kind of movement, singular, one specified directional movement, but what kind of movement you want to apply to an attack. So if I just play the game, you can see the 3 attacks in action. There we go. So we have that uppercut animation, we have over the head sort of attack, and then also the 180 technically 180, but hits both sides, 360 degree spin. Well, no, it is just a 180. I don't know what I'm talking about. But as you can see, so the 180 knocks you backwards. Okay, come on. There, the uppercut, of course, knocks you up. And then the over the head animation, or attack, if he will be cooperative, there we go, knocks you back away from the enemy and down. And actually, something that I want to add into attack info is another vector 2, or maybe 2 booleans, I don't know, something that allows you to specify whether a direction of the external force is supposed to be relative to the position of the enemy or not. So right now, y is not relative to the position of the enemy. Y is not relevant to the position of the enemy, but x is. So if you have x set to 1, it will always push the player away from the enemy. If you have it set to -1, it will actually pull the player or whatever target you're hitting in. And the reason for that is, because, well, there's no deep reason for that. That's how it works. But I want that to be optional because there are situations in which you might not want the force to be directional. I can't really think of one for the x-axis, but the y-axis, if you want to always knock the player up, you want to make sure it's always pointing up, even if the player's situated below the target. So, yeah. That's that. So there's the 3 attacks. The system is randomized. It's all based on these attack info, custom class, and the external forces. Also, you might see there's another field here, force to self. The original idea for that was to allow the enemy to sort of move throughout their animation for an attack, but I realized it didn't work quite as I wanted it to, and it looked a little jank because you couldn't specify when the movement was supposed to happen in the animation, so it didn't work out. And my gosh, I need to figure out how to pace myself with talking and words and rambles and whatever else, but that is what I'm going to be working on today. That's the idea anyway, to take out force to self and replace it with a new system that will allow you to define as many movements as you want throughout the animation and the normalized timing of when those movements should start. And then I want to create 2 additions to external forces. One, I want an external force, an optional addition to external forces in which the force is constant. Right now, the way external forces work is the same way that jumping works. So you have the force of gravity always pulling down. When the player jumps, you don't define a speed of the jump, you don't define air time or anything else. You define how many blocks or how many units you want the player to be able to jump into the air, so that it is really easy to tune. And then the speed of the jump is dependent entirely upon gravity, because of course, as soon as you jump, that jump force the force of gravity is being subtracted from that jump force until finally the jump force equals 0, and then the player starts falling. And this creates a really, really nice, smooth jump mechanic. And so I eventually just sort of tack that, or use that same concept, that same system for everything else. And it works really well. It provides really nice, smooth animations that, smoothly fade out at the end and don't just suddenly cut off. It's really, really nice. And then I have a force multiplier for a few. I added in what I refer to as a force multiplier, which amplifies both the speed of the jump and the magnitude, or not magnitude, but the gravitational or slowing force, so that the entire distance is covered in a shorter amount of time. The 2 things that I want to add to this external forces movement system, though, is one, a constant movement, which will just cause the player to, or the moving object to move at a constant rate throughout its whole movement, because there are some movements where you don't want the slow to be, or that fade out to be happening. And then the other one is what's the other one? Oh yeah, the other one I want to add in the ability to define time instead of distance. So you can say two, like, be in the air for 2 seconds or whatever. Or to be able to find distance and time and then have it automatically adjust the force multiplier so that everything works out appropriately. Yeah, that's actually better. Yeah, I always want distance to be defined. That's a core aspect. Never mind. But timing and, yeah. Constant force and time for said movement. I don't know precisely how I'm going to calculate out the time. I know it's possible because of how the system is built, because it's frame rate independent, so it is taking a set amount of time. I'm just not quite sure how that's going to look, but I'm sure I can figure it out. And then using this information, I want to create a array of movements and timings for an enemy throughout their attack animation to complete a specified movement. I think that would be, really interesting to be able to do. So that is the goal for today, or maybe not for today. That's a bold plan. That is my goal as the next step in this project. I was hopeful, and I'm less so now, but I was hopeful to be able to get some of this done on stream. At least I managed to talk about it, but this is wearing me down rather quickly, so we'll see how that goes. But let's get started and see how this goes, shall we? So the first thing to do, and the simplest thing to do, I think, is to modify forces. Turn off the enemy combat test because we'll only be messing around with the player for this one. Okay. So, first things first. External forces handler. Let's go to our class external force, and we need to add in the values. So okay. Now we have a duration and a constant force. Oh, that needs to be put. Now I just need to make them work. Right now I am just attempting to locate exactly where in the code these systems should be in place. And once I do that, I can figure out exactly what I need to do. Okay, here it is. So if ef.distance is greater than 0, am I doing this? So I'm just subtracting. Okay. So what I want to do... Oh yeah, all of this is still based on gravity. I don't want it to be based off gravity. Is gravity actually defined in this script? Oh, it is. Look at that. Huh. Well, let's not call it gravity, because that's a weird... Let's see. What is a good name for it? Fall-off force, I guess? Decay force? That sounds a little much. I mean, it's accurate, but... slow down. Let's just call it fall-off. Whoa. Whatever. Cool. There we go. Okay, so if EF dot constant force is false, then we do our normal fall off subtraction to everything else. EF dot distance equal minus equals wait, how does this work? Where does force multiplier? Does force... You have to have force... Okay, force multiplier is already taken into account. Okay, so I don't need to do that. I don't think. No. Oh, actually, I already do that, so I can just... Boom. Let's put this outside the code so it will run. The distance subtraction will run whether constant force is in effect or not. Yeah. That works fine. That seems almost too easy. I mean, it should be easy, but it seems almost too easy. Let's go to the player. Where is jump added in? Oh, we could just do dash force right here. Constant force equals true. Oh. Ooh. Oh, right. Man. I'm so not used to doing this. This is actually the first time that I have ever defined a class in this way. And it screws with me all the time. Just so used to putting semicolons at the end of these things, but you don't. And I sort of know why and sort of don't. It's a bit above my pay grade currently. But hey, look at that. Say, is that a... I see. That's problematic. Well, it was problematic. Yeah, it must be 50. Yeah, okay. Basically, what happened was when I changed the name of gravity to fall off force, I changed the variable itself, and so the variable defaulted back to its it defaulted to its default value, which in the code I had set as 5. But the gravity force I actually use for this project is 50. So there you go. Oh, that really, really confused me, as I'm sure. Man, I'm looking forward to watching that back watching that back afterwards. I think my facial expressions were something to behold. Okay, now let's go back to constant force and try this again. Yeah, there we go. So now we have a constant force. We're moving the same distance, but because the force is constant, there's no fall off at the end. It's just a hard stop. And this is why I changed the system to use not a constant force, but that fall off force that I mentioned with the jump mechanics. Because especially when dashing about, it just looks bad to suddenly stop in that manner. And this is what I was sort of mainly aiming for when I originally made it. But there are some forces that, I would like to be constant, so. There. And you can see this is, takes the same amount of time to cross. Well, actually, no, it would take less amount of time. Because because the force is constant and not falling off. Takes a little bit longer, but it is smooth. Another weird thing is I don't know why. I think something to do. I think flip should be on by default. Yeah, there we go. Yeah, okay. Anyway, it's just a little thing. Also, I need to be, when I'm trying to talk to the camera, I need to actually look at the camera. I keep looking up at my screen. It's very problematic. Okay, so constant force was actually pretty simple to get up and running. Now the big question will be to determine determine something rather. The big thing is to determine duration. That's what it is. I want to be able to set a duration, so what I need to figure out how to do is calculate the duration. So I can reverse engineer it. Let's go back to external forces. Now. How is it I am going to do this? So, when a force is originally added, we take the normalized force, so we just get its direction. And normalizing a force means that the vector has a length of 1. So if it was pointed straight up, it would be 0 on the x, 1 on the y. Point at 90, 0, 1. Point at 45 degrees, it's 0.7, 0.7. The numbers continue, but it's roughly 0.7, 0.7. Because that makes a 1 in length from the starting point to the end of the defined vector. Anyway. That gets you just the straight up direction, more or less. And then what I'm doing here is taking the square root of 2 times the distance times the fall-off force times the force multiplier. And this is a simple equation that I happened across some time ago, a couple of years, when looking for how to create a good-looking jump. Shocking, it doesn't seem like it would be hard to make a jump that looks good, but it's weirdly difficult. I mean, it's not weirdly difficult. This is just one way of doing it, but this is a very easy way of making one that looks quite good. It's just took me a long time to find it. So, but essentially what this equation does is it takes a set distance that you want to travel, and it takes the fall off force that you are using to counteract. In the case of a jump, that would be gravity, as it was named before I changed it. So you would have the distance you want to move, and then the downward force of gravity. Multiply those together, and multiply it by 2. And in my case, I had the force multiplier, which just allows you to speed up that value. And that equals a force that, when you constantly take away the force of gravity from it, will perfectly let you reach the jump height. It just works. It's as simple as that. It just works. It's great. So the question is, I have this force. Question is, oh, actually. Yeah. I'm just thinking here, actually, if I want the force to be multiplied by fall off force, if it's going to be a constant force. I'm thinking not. On the other hand, what that allows is to universalize the initial speed of the forces, because otherwise, if you had the jump value and you turned off constant force, it would start moving at a much, much slower speed and just move constantly up at that slower speed. If you turned constant force off, it would rocket up at the beginning, so it could fall off over the course of it to the end. And I'm actually now just thinking, if I want to turn that off for constant forces in order to actually be a defined force that you're applying, or if I want to change that, or if I want to leave it in so that it is universal between the systems. So if you turn constant force off, it will just constantly move at that initial force of velocity that the fall off version or non-constant force would be moving at anyway. I think for actual consistency, for perceived consistency, I'm going to leave it as it is for now, but I might change that later, actually. I didn't think about that, but I'll leave it for now. Doesn't really matter either way, but still. Okay, so I have the total force, because every time I add a force, I just run these calculations. Now, the question is, how long is it going to take to subtract out the value to cross the distance? So I subtract from the force EF force dot normalized times fall off force times force multiplier times delta time. So that is a constant rate of subtraction. So if I just multiply fall off force times force multiplier and divide it by EF dot force. So I'm subtracting. I'm subtracting fall off force times force multiplier times delta time in order to get, a value each frame to subtract from that. But multiplying by delta time just turns a sort of singular value into sort of that value. Okay. If you multiply 2 by delta time, that value would be however long delta time is. How to explain this? Okay, delta time is the length of time that a frame runs. So if you're running at 30 frames per second, it's 1 second divided by 30. If you're running at 60 frames per second, it's 1 second divided by 60. So in this case of fall off force times ef.force.multiplier, when I multiply it by delta time, I'm really just doing 1 divided by, I'm doing 1 divided by frame rate, and then taking that and then multiplying that value by fall. This is a terrible explanation. I have no idea why I'm trying to do this right now. Okay, I just need to think. For myself real quick, like. So Okay. So, basically I've just set up a couple debug statements that will tell me the estimated duration that this movement is supposed to take. Then it will record the start time in time.time, which is just a raw sort of a value of the current time. Yeah. We'll record when it started, debug when it started, debug into the log when it started, and then once the external force runs out, it will say exactly the time when it ended at, and then how long it took in seconds to create that whole movement. Now, I have no idea if my calculation up here is correct, but what this allows is now that I'm tracking the movements, I can determine whether my calculation is right or wrong. Simple as that. Also, this actually only works for one external force movement because you could have a whole bunch stacked together and it would be, I figured it wasn't worth it because I'm just testing on the one movement, so. Oh my gosh, look, it's right on the money. Okay, sweet. Actually, before I say anything too outrageous... Wait, did I remove that ability? Why would I do that? Oh. No, okay. This is application.target frame rate, which forces the application to run in a specific frame rate. Very useful for testing your game at different frame rates to see what inevitably breaks horrifically. And I've just modified that so I can access it or not. Oh, it needs to be an... Oh, that makes a lot of sense. It has to be an int, of course. Can't have a fraction of a frame rate. I mean, you could, but Unity doesn't like it. I mean, okay, you do have fractions of frame rates, obviously, but target frame rate 60. Okay, and 30. Okay, it's a little bit off, but I don't think that is a problem with the calculation. I believe that is a problem with how many frames of movement there are and how I handle that within external forces. I don't believe that is an actual problem with the calculation. I think the calculation is actually spot on. Yeah, I think the problem is this stuff here somehow. Not sure what about it would be broken, really, but... Either way, it doesn't have to be that precise. This more or less works as intended at any normal frame rate. I would like it to work better, but I think that is actually just a problem of the frame rate, and not even just the movement. I don't think it's a problem with the movement system. I think it's actually just a problem of precision of time calculation, because this doesn't take into account sort of. This is dealing with sort of actual time, as in the the longer each frame is, the lengthier the amount of time it has to. No, my brain's too fried. None of these explanations are going to make sense. The lower the frame rate, the less precise anything to do with time sort of calculation is that is based upon the frames themselves, because they are larger sort of blocks. So if you have a fraction of one of those blocks of time, you don't get to see that. You just see that next, point, like checkpoint or whatever in the frame rate. So you lose precision. So I don't think this actually is a issue at all. I could be very wrong on that. Very, very wrong. But I believe it is okay. Oh, that should be set to. Actually, I should just set it so if it's. There. Greater than 0. You don't want setting the target frame rate to 0. That seems like it'd be problematic. Actually, Unity might be able to catch that, but I don't know, so I'm not going to test it. Okay. Now that that is in place, what I want to do is set it up so that duration is taken into account. Okay, right here. So, if force to add dot force multiplier is less than or equal to 1. Oh, actually. Is equal to 1. I was just thinking about it, and there's actually plenty of situations in which I would want the force multiplier to be less than 1. So if it's equal to 1, which is the default, and force to add dot duration is greater than 0, force to add dot force multiplier equals. Okay, how am I going to do this? So basically, if force multiplier is at its default state and force to add dot duration is not at its default state, that means that I want to control this movement based upon its duration. And the way I'm going to do that is simply modify force multiplier to be the appropriate value to make up for this value of duration. And since I can calculate duration right now, what I can theoretically do is just reverse this calculation. And magically, I will get the value I need. So, force multiplier, non-existent in this setup. Wait, force multiplier is non-existent. Wait. Okay. No, what I need to do here, I have my equation, I need to solve for force multiplier. And math ensues. So it would be... So if duration equals that. And I want to solve for force to add dot force multiplier. Let's change that to just x. First, I need to multiply duration by fall off force times x. Oh, this is bold. Somebody... no. This would be a weird time for somebody to join in. I'm trying to do math. Okay, let's see. So I need duration times fall off force times x equals that. Right. But I need to solve for x. This is where I make a gigantic fool of myself. I need to pull fall off force dot x out of this equation. Somehow. Okay. You know what? Before I make a monumental fool of myself, I'm going to... I'm just going to leave this here. It has been almost an hour, and that is much longer than I intended to go for today because of how I'm feeling. So, this has been some good progress. Modified some combat stuff. Very close to getting the external forces updated to be modifiable based on duration of movement, as well as setting them to equal constant forces, which is great. Didn't get to the enemy movement system yet, or the new animation for it, but what you gonna do? Time is time. And that's how that one works. Fun fact. So, I'm going to head out for today. Good progress, and yeah, hopefully by the time I get to the next stream, I will have all of this worked out, the calculations and whatnot, and we'll be able to see some cool compound movement from enemies during their animations. That is the goal. So, hope you enjoyed it, wherever you're watching it, whether it was live or in VOD format, either on Twitch or YouTube. Thank you very much, and yeah, till next time.